Can you hear me? Online students, can you hear me now? Searching object. What is this? Now I am printing LL. How many objects available? Then following by contains method, I called by passing double quotes A. So when I pass double quotes A, what happened now? Contains method searching for the string object by using internally what? Equals. Wherever you go, same logic. First checking, is it null? No. Then calling for what? Equals method by passing every element available in the collection in the loop. Double quotes A dot equals of element in the loop starts with what? 0. Sir, starts with 0. 0 is not available now, sir. Then contains method what is doing? Starts with 0 now, starts with the first element. Starts with the first node. Then first node to dot next, second node to dot next, third node to dot next. So every time contains method searching for the object, from where? First node. Okay. Now LL dot contents of double quote, say when you call, then what happened? String dot equals of element when I pass. Element object is passing as an argument to equals method, and equals method comparing given argument object with every element available in the collection starts with the first node. Can you tell me if you remember the loop, how the loop is there? For int node equal to what I write? First, and then next node equal to node not equal to null semicolon, node not equal to null semicolon, and then what you write? Node equal to node dot next. Okay, open bracket. Inside what you write now? We have to write if condition, if what is the argument available in the object dot what is the method? Equals of. Everyone tell me, object is available in element data of node dot item. What I write? Equals method condition what write? Node dot item. If yes, then what to do? Return true. If no, just close the for loop. After for loop, then all elements start from the first node to last node. Loop is iterated, and then following by returns what? False. Is it clear? Is it clear, all the people? Then finally, what is the important point? Whenever you develop for loop, inside for loop, what you write now? We have to first start with our node first, then following by node not equal to null checking till last node. Then this is the logic of what you call contains method. Your calling method is contains by passing object. Previously vector, array list, and linked list. All these three objects are working by using all these collection object. We are calling method is same, but their internal logic is different. Vector and array list logic is the same logic, because internal data structure is what? Array. Linked list internal logic is node based logic, not array based logic. Okay, not array based logic. Then now next tell me now. Here I am writing what? I am searching for our element example class object. Tell me with what reference I am searching for? New reference. Okay, new reference I added. Searching with what? New reference. Searching with what? Same reference. With a new reference, we will get false. Why? Because equals method is not overridden. With the same reference, we will get true now, false, true. Because searching with what? Same reference. Okay, searching with the same reference. Control 1. Control F11. Look at here. We got output. Last what you got now? False and true. Okay. Then next. Now I am passing this example object. Hope you remember this test case. Try to understand. I created two example object with the same data and then added E3 searching for what? New reference, and also searching for what? What you call E4. Either new reference or with E4, both are what? New reference only, na? So both we will get what? Last two lines, false, false. Okay, false, false. Okay, then next example object. What do you write? LL dot. Now here what will get true, now false? I'm searching for which object? Searching for what? Add created one object with how many reference variables? Two reference variables, E5 and E6. Then I'm passing what? E5 as a argument. When I pass E5 as a argument, then what happen? LL dot contains of new example of 12 comma 13. Then when I pass this object as an argument, then what happen here? It is searching for new reference object. Okay, with data na with reference. Why? In example class equals method is not overridden. Then now when I call example by passing E6, then E6 is what? The same E5 reference only, because E6 and E5 both are pointing to same object. Then LL object is searching for what object now? E5 reference. Matching is found. Then returns what? True. First what it returns? False. First what written? False. Second what written? True. Is it clear, everyone? So this is the searching algorithm internal logic. Tell me here, what is the searching algorithm? Get method. Searching algorithm is what algorithm? Sorry, binary searching algorithm. And the contains method? Linear searching algorithm. Linear searching algorithm. Okay. So this is the basic idea about how the linear searching, binary searching algorithm is working background. Already I explained binary searching algorithm, remember? And next, all images, understanding flow of execution, already last Tuesday only uploaded. Hope you have already seen. I don't know whether you have practiced or not. At least have you seen? Linked list, add searching algorithm. Linked list, add searching algorithm. Searching algorithm, vector and array list continuation. This is linked list. So first I explain about what is linked list. Linked list is an implementation of both list and DQ. From which version it is implementing DQ? 1.5. So we can use linked list as collection, as list, as queue, as DQ. It's a runtime polymorphic collection. It implementing multiple type inheritance. And next, what is the memory structure? Linked list. What is the meaning of linked list? One node is linking to next node. What is the implement data structure? Implement data structure is doubly linked list. Implement data structure is doubly linked list, because one node is linking to next node is linking to previous node. Now if you want to move from one node to the another node, forward direction, we have to use for loop with a condition, with starts with what? Node first, checking condition null, increase by next node. If you want to move previous direction, and then we have to write the same logic, but node starts with last, not equal to null, node equal dot previous. And now every time we have to call node dot item for retrieving the particular item and to print. So how to travel on the node, how to retrieve the items available in the node, this is the logic you have to develop. It is a linear searching algorithm on linked list with for loop is a for loop or with array If it is a array, we have to go like this. If it is a linked list, we have to use like this comparison logic. And then following by what is the add method algorithm? Its implementation logic. What is the binary searching algorithm? It is not linear searching algorithm. It is a binary searching algorithm. How the binary searching algorithm is implemented, I have shown you in this slide. Following by then what is searching algorithm? Linear searching, binary searching. Okay, linear searching means starts with a 0 node to it's keep on going. Get method directly going to the given index and retrieving. So in array list, contains method follows linear searching algorithm, and get method follows what? Random searching algorithm. Directly go to the index and retrieving. In a linked list, contains method follows linear searching algorithm. Get method follows binary searching algorithm. Blue color, binary searching algorithm. Next, following by, I explain how the get method internal logic is implemented, how the contains method internal logic implemented. What is this binary searching algorithm? What is this linear searching algorithm? If you are searching for get method, first element if you are searching, then only 0 location. Second object if you want to retrieve 0 and 1. Third object you want to retrieve 0, 1, 2, 3. Fourth object you want to retrieve 0, 1, 2, 3. Every time get method is moving from first node to given index node. So that means, for example, if you want to find a fifth node, then it has to start from 0 to 5th. For example, if you want to retrieve all elements available in the linked list, for example, in the linked list, I have 100 objects. Then tell me how many times the cursor is moving? 100 into 100. Yes or no? How many times it is traveling? 100 into 100. Why? For each node, it is traveling start from where? 0. Whereas if you take array list get method, you want to go to 0, directly go to 0. If you want to go 1, directly go to 1. 100 objects you want to retrieve, how many times the cursor traveling? 100 times only it is traveling. So tell me, which collection is fast in retrieving all objects from the collection? Array list is fast because linked list repeatedly working. Then next following by, very important, linked list linear searching algorithm code I have written here. Okay, first it is adding logic. Okay, how the add method is executed. Then this is the memory structure for add method. And then next I explain about contains method. This contains method following linear searching algorithm. And next I have explained about get contains method for double quotes execution flow, for 5 execution flow. So if you want to go to 5th index, again you have to start from where? 0 index. Then following by index of method also same flow. Okay, there is no difference between contains method and index of. For contains method, directly return true false, but index of method, what is there? Index variable. Every time when you are moving from one node to the next node, increase the index variable, and if element is matched, return that index. These all points we discussed in the last class. If you remember, just I am showing the slides which I have uploaded for revision purpose. Okay, then following by now here I have given get method binary searching algorithm, either first of or second of, 0 to given index or size -1 to given index, it will be working. Next, removing logic. Tell me, what is the meaning of removing logic? How the remove logic will work? Let me try to make you understand. It's very simple. Whenever you are asking to remove this object, just simply this element has to be dropped, and this previous node should link to the next node, and next node should link to the its previous node. Yes or no? First, if you want to remove the second node, this second node previous node should link to its next node. Understand? Again repeat. If you want to remove which node, speak out, otherwise you will not understand. You want to remove which node? Second node. To remove second node, what is the meaning of removing second node? Just you need to link first node to which node? Third node. You must link first node to third node. If you want link first node to third node, how you can link? By storing references only, na? How the first node is linking to the second node? Because second node reference you are storing inside next variable. Correct? Tell me now. You ask to remove ll dot remove of what you are asking to remove? Double quotes B. Now this double quotes B to remove this double quotes B, what you have to do? You must link double quotes B previous node to the next node of B. Yes or no? And you must link double quotes B next node to the double quotes B previous node. Correct? For that, what I have to do? Simply copy the reference of current node next reference to the current node previous next. Don't see me. Look at the screen. Why this B is pointing to the 5 node? Because 5th node reference is available here. Yes or no? Now the reference whatever available here, what is the reference here? 10, 10, 20, 20, 30, 30. Okay, let's say LL is 10, 10. First node is 20, 20, 30, 30, 40, 40. 40, 40 reference is available here. So it is pointing to the next node. Am I right? Now what I have to do? This 40, 40 reference available here should copy here. Yes or no? If I copy it here, what happened? Now, previously available 30, 30. Sorry, let me take a confusion not. Let me take like this. This is what? 30, 30 assume. Okay, now third object reference is 30, 30. And what is the value available here? 20, 20. 20 because in the first node 20, 20 available is pointing to the next node. Second node contain 30, 30. That's what is pointing to the third node. Now tell me. Here 30, 30 reference. 30, 30 reference. What I have to do? Copy into previous node. So that 20, 20 replaced with 30, 30 and previous reference is gone. Now it is started pointing to the next node. Next node, who is next node? 30, 30. Understand? What I want? I want remove this object. Remove this object and what is the meaning of it? Remove this object means what the meaning of it? The meaning is I have to mark this object. Yes or no? I should drop this object and this node I have to link to the next node. Who is the next node? 30, 30. For that, what I have to do? I should move the references. Everyone tell me the logic for moving the references. What I have to do? I got the method. Public void, okay, boolean, whether removed or not removed. Method of remove of object obj. Yes or no? First, where this object obj available, I have to search. How to search? For loop. Now tell me, binary searching algorithm or linear searching algorithm? Linear search, because it's by object. What do you write now? For of node equal to, start from where? First, and then node not equal to null, and then next node equal to node dot next. Okay, and then here what I have to do? Now what I have to do? Here in the for loop, what I should do? I should write if condition. If, what do you write? Obj dot equals, comparison, equals of, what I should pass? Node dot item. Okay. If equal, then what logic I have to write here? Removing logic. Previously what written? Return true. Return index number. Now what logic I have to write now? Removing logic. What is the removing logic? Tell me. Everyone. What is the removing logic? Presently this node only, this second node is this node reference. If node dot item equal to current node, which node I have to remove? This node I have to remove. Removing this node means what? The connections of this node I have to remove. This present node, previous node should pointing to node dot next. What logic I have to write? Node dot. I have to go to previous node now first. How to access present node, previous node? Previous. Okay. Then from the present node, I went to where now? Previous node. Achana? Now previous node, which variable you want to access? Next. Dot next. Equal to. Then what I should write now? Now dot next. What I should write now? This 2020 should replace with what? 3030. Where is 3030 available? Node dot next. Try cheyali. You have to try to tell node dot previous dot next equal to node dot next. Clear? Adhaina sir. Don't feel shy to ask if you don't understand. I'll explain again. Understand? If you are using your eyes, you will not understand. That's why linked list is the most difficulty topic. Because why? Here you have to put your brain. Just by eyes, ears, you cannot understand. Remaining concept just by eyes and ears you can understand. Now you have to put your brain. Your brain will come only when you are using your mouth. Now tell me, what is the node dot next value? 3030. Copied into node dot previous dot next. Node dot previous dot next. 2020 replaced with 3030. Then this reference is gone. Now it is pointing to the next node. Next, tell me now. My next node, the current node next node should, the current node next node previous should point into whom? Current node previous. And Japan logic, what I have to write the statement here? Node dot. You want to go to where now? Next node now first. What do you write now? Next dot. That next node, what you want to change? Previous. Previous equal to node dot previous. Okay, na? That's all. Na? This node dot previous I have to copy into next dot previous. Next value should copy into previous dot next. By moving these references, what are the references are gone? The references are gone are number one. What are the references gone? Number one, this reference is gone. Number two, this reference is gone. Mari, what about this reference and this reference? If you want to remove, all the links has to be destroyed. Na? 2 links I have removed. Then the remaining 2 links also I have to remove. How to remove? Here what is there? 3030. This 3030 I should remove. Here what is there? 1010. This 1010 I have to remove. Okay, na? Then now tell me here what should I do now? I have to change. What I should change? Node dot previous. What I write? Null. Super. Excellent. Next node dot next equal to null. This is the logic of remove. Now tell me, when you want to remove the element from the linked list, how many nodes you are moving this side, that side? 0 nodes. Are you moving the items from one line to one location to another location? Anywhere you are changing? No. 0 elements you are moving. What you are doing? Simply just changing the links. Do you remember? Linked list is fast in remove and search and insert and removing operation. Linked list is fast, whereas array list is slow. Why? Observe. If you want to remove element in array list, this is my array list array. Okay. Array list array. 0, 1, 2, 3, 4, 5. Okay. If you want to remove the object here, double quotes B. Okay. Already we have multiple objects, 100 objects available. You want to remove this double quotes B. Can you just go and abracadabra remove and remove? Not remove. Okay. For example, this is my text. Okay, I'm writing A, B, C, D, E, F, G, H, I, J. Okay, this is what? A, B, C, D, E, F, G, H. This is my text. I want to remove what? B. Everyone watching? Online students? I am removing B. If you want to remove B, abracadabra, remove and remove? No. You have to place the cursor here and click on what? Delete button. And in which position you placed? This is 0. This is a 1. Cursor position here what? 0. Here cursor position is what? 1. In one location, cursor place, you click on delete. Everybody watch. What happened? B, place the cursor position, one location. When I click on delete button, what happened? Deleted. How deleted? That is what my question. Deleted correct. How deleted? That's what my question. You are saying deleted, perfectly right. But how it is deleted? That's what you have to identify. This is my, what do you call a array 0. Zero, 1, 2, 3, 4, 5, 6, 7. Okay. Everyone carefully observe. This is our 0, 1, 2, 3 locations. Okay. I want to remove what? One location. Then go to one location. What am I doing? Remove. What happened? After removing, what happened? Now tell me. Here, what happened? Elements. Elements and A, B, C, D are the elements. What happened to the elements? When you remove one element, what happened? Elements are moving to the previous node. Yes or no? This is the previous location. When I remove B, B removed? No. What happened? Remove means there is no remove operation. In the computer world, there is no remove operation. Always remove is done by replace. How? All previous next location elements are moved. Next location elements are moved. Next location elements are moved. One location right. Next location elements are moved. One location right. Understand? For example, here I have total in the collection. In the collection, assume I have 100 elements available. I am removing first element. Then totally 99 elements has to be moved to the left. Na? If it is linked list object, if it is linked list object, what happened? If it is a linked list object, what happened? Tell me. If I want to remove the B, are you moving elements? Just links are changing. Just I am changing link. This node next we are pointing to previous node next we are pointing to this one, and then this link is gone. Yes or no? Finally tell me, very important, why array list is slow in execution in insert and remove operation? Why linked list is fast in insert and remove operation? In array list, we should move elements from one location to another location. In a removing operation, I should move elements to the previous location, and in the insert operation, I should move elements to the next location. So because elements are moving from one location to another location, number of copy operations are increased, hence performance issue is there. Whereas in a linked list, we are not moving the elements, just we are changing the links. Totally, how many copy operations are available here? Four copy operation, right? Just the references, four references are copying. Hence, finally, array list is fast in retrieving, storing, retrieving. Array list is faster. Searching and inserting and removing. Inserting and removing linked list is a fast. So when to choose array list and when to use linked list. If my more operations are store, then retrieve, array list is best. If my more operations are store, after that insert and remove operations are more, and sequential if you want to retrieve, then what is best? Linked list is the best. So this is the theory point we discussed in the first day, and this is the practical explanation. Okay, finally, what happened? Finally, this node is gone. Look at that. These links are gone, and the node is gone. Understand? And now, finally, after this remove operations completed, this object is pointing. And last, very, very important, after removing element, we have to write what? Size minus minus. Because one node is removed, na? Same logic for insert logic. I want insert new node. If you want insert new node, what I have to do? Now, previously, this node is pointing to it, inserting logic. Now, I have to attach one new node in between. For example, here, this is the node I want to insert. Then what to do? Just references I have to change. Okay, previous references I have to change. Now, finally, three references swapping. Okay, why insert method is taking more less time? Because only three references are swapping here, whereas in array list, every object, array list elements must be moved to the next location. So that's why it is become what? Fast, slow. Okay, fine. So with this, we completed linked list all the points, and this is a theory note. The linked list is a collections framework collection. It is available from Java 1. It is an implementation of list interface. We must use linked list when the more operations are insert and remove objects at the beginning and in the middle of the collection. Next, for retrieving objects only sequentially, we must choose linked list. Linked list is a non-synchronized. It is a ordered collection. Implement data structure is doubly linked list. Following by default capacity 0, incremental capacity is 1. All four types of objects allowed. Null is allowed. Multiple objects are stored in insertion order without index. We can retrieve object only sequential order. In searching and removing operation inside contains index remove methods, internally equals method is called, and it is executed from our class. Linked list class provides below two constructors for creating its instance. Two constructors available. Array list how many? Vector how many? 4. Linked list, array list 3. Now linked list 1. What is missing now? Capacity specifying constructor, because by default capacity is only 0. You cannot specify default capacity. And the same program we have written. Okay. Let me update this file because contains method is missing here. So with this, we 100% all points, including implementation logic. If interview ask a question, develop your own linked list. Also, I have explained. Each method internal logic clearly have explained. Now, what you have to do? Listen, like how I have developed in your class, like how I have developed NIT collection, NIT map, like that. Can you also develop NIT linked list by your own today? Like how we develop NIT collection class, all operations in this example, I want to write the logic for what? NIT linked list. Will you write? This NIT collection is nothing but array list. This NIT map is nothing but hash map. Now I want you to develop NIT linked list. You try. If you are not getting an idea how to write the code, it's very simple. Open this linked list class. Which method you want to implement? First you try by your own. Size method logic, you try by your own. ToString method logic, try by your own. Add method logic, try by your own. If you are not getting an idea how to develop, open the source code. Press F3. Source code is open. Open source code, F3. What are the logic they have written? Just in that, how many statements you copy and place. You write your own. Understand? So today, if you spend the time on linked list implementation code, any kind of logic you can easily develop in the future by, in the interview or in the company also. You will not get any problem. Okay. So hope you will try today. Okay, now with this we completed linked list. Then tomorrow we will try to understand array list. Sorry, tomorrow we'll understand stack and performance on all types of collections. Tomorrow stack completed, and also performance in among all these 4 collections. Which collection is fast? Practically we will try to understand with an example. Okay, don't miss tomorrow class. Thank you. That's all for today class. So tomorrow same time 8 o'clock. Today little I came late by 15 minutes because of some traffic jam problem. So I told you now, at my house outside, some road construction is going on. Some idiot placed the vehicle directly opposite. So that's why I came late. So tomorrow I will try to come early as much as possible. So thank you. See you tomorrow. Yeah, more 4 days. Pratiksha, more 4 days. Yeah, thank you.